For as long as we've gazed up at the night sky, Mars has captured our imagination, a planet glowing red with the promise of mystery and perhaps a second home. But with all our dreams of Martian colonies, advanced rovers combing its soil, and billionaires pitching the idea of interplanetary living, one big question remains: can humans actually live on Mars? At first glance, Mars feels more like a death trap than a dream destination. The freezing temperatures, the razor-thin atmosphere, and the lack of any big markets to buy sunscreen all scream, "Stay on Earth." But here's the thing. Mars also holds incredible potential. It's the most Earth-like planet in our solar system, a cosmic neighbor with a 24.6-hour day, polar ice caps, and traces of ancient rivers carved into its surface. In many ways, it's the perfect candidate for humanity's boldest experiment yet, turning an uninhabitable wasteland into a second home. Let's start with the basics. The first problem with moving to Mars is, well, staying alive. The Martian atmosphere is mostly carbon dioxide, around 95% to be exact, whereas humans, last time we checked, are pretty partial to oxygen. Breathing unfiltered Martian air would be about as pleasant as trying to inhale underwater. That means any hope of long-term living starts with building habitable environments, like domes or underground shelters, where Earth-like conditions, air, pressure, and temperature, can be simulated. Speaking of temperature, here's another hurdle. Mars is cold, and we don't just mean grab a jacket cold. With average temperatures hovering around -80 degrees Fahrenheit, you'd need serious engineering to insulate habitats and keep equipment running smoothly. Yet, scientists are exploring advanced building materials, and innovations like solar-heated structures could keep living spaces warm and functional, even during the planet's brutal winter storms. But then there's the big glaring issue that gets attention in every sci-fi space movie: water. Fortunately, this is where Mars surprises us. Thanks to years of exploration by NASA's rovers and orbiters, we know there's water locked up in Martian soil and ice. Extracting it won't be easy, but it's doable. Future colonists might use machines called Mars ISRU systems, in situ resource utilization, to melt ice or pull water vapor straight out of Mars' thin atmosphere. With enough ingenuity, that water could be purified for drinking, used in agriculture, or split into hydrogen and oxygen to create rocket fuel and breathable air. It's wild to think about, but unlocking Martian water could hold the key to survival. And speaking of eating and drinking, let's talk about food. Growing crops on Mars might sound impossible, but science fiction isn't as fictional as it used to be. Plants need light, water, and nutrients, all things we can, in theory, provide on Mars. Research on Earth, in places like Antarctica or lava caves in Hawaii, has already demonstrated that crops like lettuce and potatoes can thrive in controlled environments that mimic extraterrestrial conditions. Add to that closed-loop systems for recycling water and nutrients, and you begin to see a possible pathway to a sustainable food source. It might not be Michelin star dining, but it could keep humans alive, and maybe even a little healthy. Then there's the question of gravity. Mars's gravitational pull is only about 38% of Earth's. That means theoretically you'd weigh less, which sounds awesome, right? Jump higher, lift heavy objects, hit new personal records on leg day. But here's the catch. Long-term exposure to low gravity can mess with your health. Bones thin out, muscles waste away, and without constant exercise and medical monitoring, the human body could struggle. Scientists are still figuring out just how much gravity we need to stay healthy, and artificial gravity, created through spinning habitats or centrifuges, might be part of the solution. Creating artificial gravity through spinning habitats or centrifuges offers a glimpse into a future where life on Mars could be sustainable and healthy. Next, we've got cosmic radiation. Mars doesn't have a magnetic field to shield its surface from harmful solar and cosmic rays. For astronauts and future settlers, this is a serious concern. Without protection, prolonged exposure could drastically increase cancer risks and damage the nervous system. But here's where clever science comes in. Martian habitats could be built with thick walls made from Martian regolith or even constructed underground to provide natural shielding. More advanced solutions, like electrostatic force fields, are also being explored. It's a challenge, no doubt, but not an insurmountable one. Of course, living on Mars isn't just a technological question, it's a psychological one too. Imagine small groups of people confined to tightly packed habitats, with no quick way to call home when things get tough. Isolation, homesickness, and a constant backdrop of life-threatening danger could weigh heavily on mental health. The lessons we're learning from the International Space Station and Antarctic research stations will be invaluable here, designing habitats that foster community, comfort, and a sense of purpose. After all, the first Martian colonists won't just need survival skills, they'll need resilience. Now let's address the elephant in the room. Getting there and staying there. A trip to Mars is no weekend getaway. It's a 6 to 9 month journey, depending on orbital alignment and mission plans. Traveling through space for that long would expose astronauts to microgravity and again, radiation. But once on Mars, the biggest hurdle will be self-sufficiency. Shipping supplies from Earth indefinitely isn't just impractical, it's unsustainable. Launching rockets is expensive and time-consuming, so future Martians will need to produce their own food, water and energy using what's available on Mars. And yet, despite all of these challenges, living on Mars doesn't feel quite as impossible as it used to. With breakthroughs in science, engineering, and human adaptability, every barrier feels like another puzzle to solve, another step to take. And that's the beauty of it, isn't it? The question of whether humans can live on Mars isn't merely a matter of logistics, it's a challenge to the very core of who we are as a species. We're explorers, pioneers, dreamers. We left caves for the open grasslands, crossed oceans in rickety wooden ships, and leapt into the sky with fragile wings. Mars is the next great adventure. So can humans live on Mars? The honest answer is, not right now, but someday. Absolutely, it's going to take time, investment, and the collective brilliance of humanity. But whether you're looking at the red dot in the night sky or holding on to the hope of humanity's survival, the question of Mars isn't just about the mechanics. It's about the future we dare to imagine. And if history is any clue, we're never better than when we reach for the stars. What do you think? Could you see yourself living on Mars, or is the red planet a frontier for the generations yet to come? Until next time, keep dreaming big. Mars might just be closer than you think.